Today we will discuss about ionization, enthalpy or energy. What is ionization energy? Means the minimum energy which is required to removal of an electron from the outermost valency shell of an isolated gaseous atom is known as ionization enthalpy. For example, if atom consists nucleus, then the orbits are represented like 1, 2, 3. The differentiating electron is present in the third orbit. Then the minimum energy which is required to remove of this electron from its valency shell is known as ionization energy or ionization enthalpy. So, for example, atom is represented as M. Then, by the removal of an electron, atom is represented as M plus. Means it is known as uni-positive ion. Uni-positive ion. So, by the removal of an electron, so it gets plus E. Okay. So, where the first ionization energy is represented with IE1. Okay. So, here ionization energy is also called as first ionization energy. It is represented like this equation. Okay. So, see here first ionization energy. So, both are same. So, what is first ionization energy means? Where the minimum energy which is required for the removal of an electron from the outermost valency shell or orbit of an isolated gaseous atom is known as first ionization energy. It is represented as IE1. Okay, yeah. Next, second ionization energy. It is represented as IE2. What is second ionization energy? Means where the minimum energy which is required for the removal of an electron from the uni-positive ion. So here we are getting uni-positive ion in first ionization energy. So it is represented as M plus. Okay. So after removal of an electron, then number of protons are increases and forms bivalent bivalent ion. So here it is electron. Then it is represented as IE2. Okay, now the minimum energy which is required for the removal of one electron from the uni-positive ion is known as second ionization energy. Now, where the second ionization energy, it is always greater than first ionization energy. So means IE2 is greater than IE1. And why? Means, for example, here when you observe any atom, then the number of protons present in neutral atom is like 5. Now the number of electrons also 5 in neutral one. By removal of an electron, the number of electrons are 4 and the number of protons are 5. Okay, so protons consist where positive charges, where electron consist negative charges. Okay, so here it is in uni-positive ion. So when we observe here, the number of protons are greater than the number of electrons. So always the protons are present in the nucleus. Okay, so where the number of protons are increases means the nucleus attractions are increases on the outermost valency shell electrons. Okay, so the nucleus attractions are increases on the outermost valency shell electrons, as well as when the nucleus attractions are increases, then the atomic size is also decreases. Atomic size is also decreases. So, but here the removal of one more electron from the uni-positive ion, then the energy is increases. So IE2 is greater than IE1. Okay. So for example, here when you observe the third ionization energy. Okay, third ionization energy means the energy required for the removal of an electron from the bivalent ion. So means after removing of first ion, we get M plus 2 ion. So it is known as a bivalent ion. So the electron is removed from this bivalent ion is required more energy as compared with the second ionization energy. So means where for the removal of n number of electrons, where the energy is represented as IEN. So IEN is always greater than IEN minus 1. Okay, so like that here IE3 greater than IE2 greater than IE1. Okay now? Yeah. So we always the second ionization energy is greater than first ionization energy. For example, we will see oxygen atom. So where oxygen atom atomic number is 8, where the number of protons are 8 and the number of electrons are 8. Okay, so you should write the electronic configuration as 1s2, 2s2, 2p4. 1s2, 2s2, 2p4. Where the outermost valence shell means it consists of total 6 electrons. So because of your 2s orbital consists of 2 electrons and 2p orbitals are having 4 electrons. Then see here nucleus, then first orbit, second orbit. Then 6 electrons are present like 2s2, 2p4. Okay, yeah. So 2p4 means we should write like 1, 2, 3 and 4. After removal of one electron, the number of electrons present in O plus ion. So here 7. 7 electrons are present. Means we should write electronic configuration as 1s2, 2s2, 2p3. 1s2, 2s2, 2p3. So when you observe the outermost valence shell electronic configuration of O plus ion. So means 1, 2, 3. Okay, so here how many electrons are present? Means 3 electrons. And we know here the atoms which consist of filled orbitals or fulfilled orbitals, they get more stability. So here we required more energy for removal of this electron from the unipositive oxygen ion. Okay, so where the second ionization energy for oxygen is always greater than the first ionization energy of oxygen atom. Okay now, so why? Because means where the nucleus attractions are increases as well as atomic sizes decreases. It is the reason. Now we will see about factors which affect ionization energy. Factors which affect ionization energy. So first one is atomic size. Atomic size. Okay. So where atomic size is increases, then ionization energy is decreases. Where atomic size is decreases, ionization energy is increases. So always atomic size is indirectly proportional to ionization energy. Okay, it is always indirectly proportional to ionization energy. So see here, it is the atom and it is the one more atom. Okay, so here atomic size is greater than the first one. Okay, atomic size is greater than the first one. So means here the nucleus attractions are more on these valency electrons as compared to here. Okay, so if atomic size is increases, you require less energy for removal of an electron. So where it is indirectly proportional to ionization energy. Now the second factor is the nucleus charge. Nuclear charge. So nuclear charge is depends on the number of protons present in the nucleus, means central of an atom. Okay, if the nuclear charge is increases, then the attraction forces of nucleus and the outermost valency electrons are increases. So we required more energy for removal of that electron. So means where the nuclear charge is directly proportional to ionization energy. Okay, so for example, here it is the nucleus where these are the orbits. If the nucleus charge is, for example, 6 protons are present, then in the outermost valency shell it consists of electrons. So if the number of protons are increases, for example here atomic number is 7, then the nucleus attractions are increases, but where the differentiating electron is entered into the same orbit. Okay, so when the nucleus attractions are increases, the atomic size is decreases. So due to that we require more energy to remove of this electron. So always the nuclear charge is directly proportional to its ionization energy. Okay, now the third factor, so penetration power. So penetration power of orbitals. So generally S, P, D of these are the orbitals. So these orbitals are having a different shapes. So where S orbital is having like a spherical shape. Next P orbital is having like dumbbell shape. Then D orbital double dumbbell shape. Then F orbital. So it is eclipsed or also called as a four-fold axis shape. So means from top to bottom. So when we are moving from top to bottom, where the difficulty is increases. So when the difficulty of these orbitals are increases, where the penetration power of these orbitals also increases. Okay, now so means where S orbital is having like a spherical shape, if the valence electron present in the S orbital, then it can easily attracted by the nucleus. If the electron or valence electron present in the F orbital, so due to four-fold axis shape of F orbital, it cannot easily penetrated. Okay, it cannot easily penetrated or attracted by the nucleus. So we required less energy for the removal of an electron from the F orbital. Okay, so when we observe the ionization energy of the electron which is removed by these orbitals are having like this order, means if the electron is present in the S orbital, then the ionization energy for S orbital electron is always greater than the P orbital and greater than D orbital and greater than F orbital. Okay, so why? Because means if the penetration power is increases, ionization energy also increases. So means the penetration power of orbitals are always directly proportional to the ionization energy of an atom. Okay, now the fourth one. So half filled, or full filled. Orbitals, half filled or fulfilled orbitals. So where the atoms which consist either half filled or fulfilled orbitals, then they get more stability. We know if the stability of an atom is increases, then the removal of an electron will require more energy. Okay, so means where the atoms which gets either half filled or fulfilled electrons containing orbitals, then the ionization energy of those atoms also increases. For example, here nitrogen, it is having atomic number 7, and oxygen having atomic number 8. So we write like 1s2, 2s2, 2p3. Okay, so 2p3 means here it is having the half-filled orbitals in nitrogen atom, where for oxygen 1s2, 2s2, 2p4. So it is having more than half-filled electrons. Okay, so the energy which is required for the removal of an electron from the nitrogen atom is always greater than the first ionization energy of oxygen atom. Okay, now so why? Because means where the nitrogen consists of filled orbitals. Okay, for example, here if we can compare with the oxygen and O plus ion. Okay, so where oxygen consists 8 atomic number, means 8 electrons in O positive ion. So oxygen positive ion is having 7 electrons, means we should write electronic configuration like nitrogen. So means 1s2, 2s2, 2p3 for O plus ion. So means here it consists of filled orbitals as compared with the neutral atom. So where the second ionization energy of oxygen is greater than first ionization energy of oxygen atom, means a neutral atom. Is it clear? Okay. Now atomic radius. Okay. So where atomic radius is depends on atomic size. Okay. If atomic radius is decreases, ionization energy is increases. If atomic radius is increases, ionization energy is decreases because of nucleus attractive forces are decreases on the outermost valency electrons. So means where atomic radius is indirectly proportional to ionization energy. Okay, now so atomic radius is inversely proportional to ionization energy. Now the sixth one is the screening effect. So screening effect means where if it is an atom consists of nucleus. If the third orbit is the valency orbit. Now here the electrons are present in first orbit and second orbit. So these are known as inner orbit electrons. Inner orbit electrons. So where the inner orbital electrons are decreases the nucleus attractions on the outermost valency shell electrons. Okay, so the inner orbital electrons decreases the nucleus attractions on the outermost valency shell electrons is known as a screening effect. Means when screening effect is increases, nucleus attractions are decreases on the outermost valency shell. So it is always indirectly proportional to each other. Means if the screening effect is increases, then the ionization energy is decreases. So means it is inversely proportional to each other. Okay, thank you.